Good morning still. I think the other video will be too long, so I'm splitting this up. I had planned to have this with the previous one, but if it's too long, I'll just split it up. We're going to look at a special case of angular motion, and that is when the angular acceleration is constant. Way back when, before reading week, in linear motion, we looked at the special case of constant acceleration, constant linear acceleration. For example, an object in free fall. Constant acceleration. G, 9.8 meters per second pointing down, was the acceleration constant in the y direction, and 0 was the acceleration constant in the x direction, something in free fall. We ignore the effects of air, of course. We could have just an object in a constant acceleration in x that could be different than 0. We could have an object in y with an acceleration different than 9.8. Doesn't matter. As long as the acceleration was constant, we can use these three equations here in blue always. We can do the same thing in rotation. The special case of rotation of angular motion is that the angular acceleration is constant. It can be 0, it can be positive or negative, which means that the object wants to rotate more and more counterclockwise or clockwise. But if it's constant, we can do the same thing. The translation of these three equations into their angular form is this. And these are it. The only thing that changed is the x for theta, the v for an omega, the a for an alpha. T is external to these motions. It is time. It always flows at the same rate the surface of the Earth, so it stays. And you'll see they have the same shape, and hopefully I'll be aligned somewhat okay. You see that the displacement is equal to the initial velocity times the time plus 1/2 the acceleration times the time squared. We have the final velocity is the initial velocity plus the acceleration times the time. We see that the square of the final velocity is the square of the initial plus 2 times the acceleration times the displacement. All that's left to do now is to use these three in problems and solve the problems and manipulate. We'll do the same thing that we did before. We'll need to establish what we know in all of these equations, find what we need in there, and then solve the problem, which is a beast in itself. I agree, but the broad lines are this. Now, I strongly recommend that you use these three equations in red to solve your problems. Get used to writing them, get used to reading them, get used to understanding what they mean, and have a note somewhere, have your notes with the definitions of those variables and what they mean and how they go together, how they're linked also to the linear variables, because sometimes you'll be asked to start or to find an angular quantity and translate it into its linear quantity. Sometimes you'll be asked to reverse. So go practice, and I'll see you in the next one.